Welcome, everyone. My name's Mark Hughes. I'm the creator of TeachMePCB and co-facilitator of this year's cohort, and I've got exciting news for you. You see, I've been really busy, and I didn't have time to program and this board, which actually is a good thing because it turns out I put all my LEDs on backwards. Doesn't matter. Um, I have one of the smartest people I've ever met, an excellent firmware engineer, and just an absolutely beautiful human being, um, Uri Shaked of WokWi fame, and I'm going to bring him on now. Hi, buddy. How are you?
Hey, really excited to be here, and I really appreciate the background of the stream. It really adds to the atmosphere.
Hey, hey, buddy. We're excited to have you. Like, I can't even tell you how excited. I've been telling everybody I know. Maybe tell us a little bit about yourself and what you do, and we'll go from there.
Okay, so as Mark said, my name is Uri. I'm from Israel, and I'm enjoying solving problems, usually using electrical engineering, web, and other technologies. So basically, uh, coming up with interesting solutions, sometimes not really practical solutions to problem using technology. And nowadays I'm working on a tool that could be useful for, I hope, at least some of you, which I'm going to, Mark and I are going to introduce today. And, I've started like making PCBs, I think that was 15 years ago, just because I wanted to create some project and it needed a custom PCB. So I just asked a friend, how do I create a PCB? And he happened to know. He told me, you could download this software and then you try things until it looks okay. And then you print it on a piece of transparent paper and iron it over the board and use some chemicals. And I was like, chemicals? And he's like, no worries, I will give you the chemicals. Just get it, get this transparent with film with the PCB, and I will show you how to do the rest. Oh man, that was a messy process, but I did get working PCB, something that could connect over to USB using a very prehistoric microchip chip. They were actually back in the day. They would send you free samples. So I got a few free samples, made a PCB, and then had my first. It was Arduino like board in terms that you could program it over USB, and it had some GPIOs exposed. So I used it to as like a prototyping board for my other projects. But then I took a very long break from making PCBs, and I think I came back to it like 3 or 4 years ago when it was suddenly very affordable and relatively easy to to design and manufacture PCBs. And I got to tell you something, everybody who is taking this course, it can be very addictive. Once you know, once you like have the skill, you have the knowledge, and you start developing your muscle for designing PCBs. And as Mark said, you will always make mistakes, and even if it works perfectly on the first time, there is always something that you want to do better for the next revision, and then the next one and the next one. So it's really easy to go down, to go deep down this rabbit hole. But it's it's a fun process, and you can make really useful things. Here is like something I made a few about a year ago. It's it fits with the Halloween theme for this from this weekend. But it's actually hardware riddle. Like you have some code running in this microprocessor, and if somebody is interested, I can send you the link to the code. It's a cryptic Arduino code that running on this microprocessor, and you have to do something with the board in order to extract some secret string that is in this chip. And unfortunately, you are not allowed to use any kind of electrical connection, so no wires, no nothing. There is another way to make this spooky skull tell its secret. So it's a really challenging hardware riddle, and I was able to bring this from an idea into a finished product. It's not a complex PCB, but having the skill and having the knowledge allowed me to just do it without relying on anyone who would like. I think if I would reach out to an electrical engineer and tell them, I need a really simple PCB, but it has to be in the shape of a skull and with a golden tooth, they would like, huh? I mean, we came to do work here, not to mock around. So I was able to, do this. So I've seen some of the designs in the Discord. I think somebody did a manta ray shaped board, right?
They did.
So I mean, yeah, unleash your creativity. Now you are getting the skills, and you can not only do functional stuff but also fun stuff, and combining fun and function together. That's what. So you asked what I do. That's one of the things that I really like to do. Fun, function, technology, put them together.
And just so you guys know, Uri is the reason that you guys weren't allowed to make rectangular boards. I was about to make one, and he
Really?
talked me out of it. Remember that one?
I now when you mention it, I remember there was something. I don't think I talked you out with it. I think I just sent you some board that I made, like a photo of it, and then or no, I sent you a few boards that so going back about just before this horrible COVID times. I also run a small PCB workshop here locally, and people made some really brilliant designs. And I think I sent you photos of a few of those designs, and then you were like, okay, no way I'm going to make this old school rectangular board. Like, let's give people the chance to be creative.
Yeah. No, yeah, that was exactly the conversation. You talked me out of it. I was going to just do something like, that was good. It was a good thing. It wasn't like you were forcing your opinions down my throat or anything. You inspired me.
Yeah, the other way around. I didn't even know I was doing it until now. Like I was, here, this is what I did, and you were like, yeah, why not?
So, well, thank you so much for joining us here today. It's absolutely been my pleasure to get to know you this last year and a half, or whatever it's been. And I really thank you for helping me out with the course, with the firmware programming. So how would you like to get started and tell people about your project WokWi and maybe get them to participate?
Sure, I would love to. And I don't know if there is like any way to like see the people in the chat or something like that. But if there is a way to get to see the comments, then I would love to know. Oh yeah, I see there are like already some questions, and Manuel is asking about good quality and affordable PCBs overseas. Yeah, that's a good question. It really depends on what you need, but for simple things, I always go to China. So I see there is like a way to see the comments. So I would love to know what kind of programming background people here have. Like, do you work with Python, JavaScript, C++, Arduino? So just feel free to, blast your answers in the comments as quick as possible, so we have a quick overview of what people are familiar with.
Just so you know, there is a little bit of a delay, so it'll be about 30 seconds before those come in, and then I can share them on the screen. So, but yeah,
all right.
Share what software programming that you guys prefer the most, and I'll share that with Uri here in a moment.
So while we are waiting, I will answer the previous guy's question. I use GLC PCB, and they're usually okay. PCB way are a bit more expensive, but I had good experience with them. all PCB, and for larger orders, I usually reach out to. Sometimes I reach out to more obscure PCB manufacturing warehouses. Just because sometimes you need something else to be done, like firmware programming, and the big PCB manufacturers may not want to do it, especially for you, or it may add delays or extra charges. So sometimes, like the smaller facilities, they can do more custom process. If you need like firm programming and packaging and labeling, they can do it all for you. So I can say that I had like pretty good experience working with manufacturers from China. There is also Eiler from, I think, Germany or the Netherlands, which I used once and they were good. So I'm seeing there is like a lot of C and Python, right?
Yeah, a lot of C and Python. We've got some Android developers here, C++, so it's all C, embedded C. So web developer here. So a little bit of everything.
Yeah, it seems like Python is sort of pretty popular. So, okay, I think it's time to. Good point about Osh Park. You asked about overseas, so I immediately went to overseas, but Osh Park is great. I think the first few PCBs I manufactured overseas, for me, US is overseas, so it
Yeah.
counts. They were manufactured by Osh Park, and they were definitely, as they say, perfect purple PCBs. Perfect purple.
Perfect purple.
Um,
Yeah.
I think the first one, or one of the first PCBs I did overseas was a small heart-shaped PCB that I gave as a gift to my girlfriend with a few. It was pretty hard to source them, but apparently you can get pink LEDs. So it had like
Ooh.
pink LEDs around the border, and it was like a keychain thing that you can attach to your keychain with a small switch and a battery and like a small, tiny flashlight. So yeah, definitely Osh Park, and they have now this After Dark, which is not purple, but it's still really cool because you get to see all the traces. So yeah, and I also like there is this guy Drew Fustini who works for Osh Park, and he publishes a lot of cool stuff about open source hardware. So apart from the Osh Park service, this guy is also cool.
Yes. Let me say one thing, because we do have quite a few overseas visitors. This is a completely fair point. None of the sponsors expect you to buy anything. What they would like is the chance to quote your project. That's it. If it's 10 times the cost, if it's 5 times the cost, go spend your money somewhere else. Shipping to wherever you're at, France, Spain. Last year we had some users in Colombia. It's just not cost effective, so don't feel obligated. Just give them the chance to quote. That's all anybody's asking for. That's it. And other than that, run around guilt-free. Spend your money how you see fit. Is that fair?
It sounds fair. And one more piece of advice: if you are sensitive to price, there is a site called PCBshopper.com, and you just fill in the requirements, how many layers you need, colors, etc., and they would just give you a bunch of quote for all the major manufacturers. I think both in the US, in Europe, in China. Yeah, exactly. So that's a good way to get a quick overview if you get a quote and you think it's too expensive, what others would charge for the same service. And this is only PCBs. There is like assembly, which is a complete different subject. Like PCB is pretty easy. You choose a bunch of parameters, you get a price. Assembly, every manufacturer had like different pricing strategies, so it's hard to compare them unless you know exactly what you are building. And even then, like there's they have to source the part. And if you are like manufacturing in China but using parts from GGK, they will have to be imported from the US, and that can add 2 or 3 weeks delay. So it kinds of get complicated when you want assembly. One advantage of working with somebody in your own country is you speak the same language. That can be really make a big difference when you have some more complex project. So my advice, if you have something that you are doing like for hobby and you don't really care doing a few iterations, then go for the cheaper option, and that would probably be fine. But if you care about the turnaround time and quality, then sometimes cheaper will be more expensive. So yeah, I think it's a good time after this long intro to get into the topic of what is WokWi. So I will share my screen in a moment. Let's see if I can explain it, and then I will show it and see. I want to see if in the chat if I explain it well, because I'm still working on figuring out how to explain this. So basically, WokWi is an online simulator for Arduino, Raspberry Pi Pico, and other kind of microcontrollers and electronics. So you can connect all the parts, write the code, write in your browser, run the simulation, see the result. And the idea is to get really fast iteration. So you modify something, you see the result. You don't need like to upload firmware. You don't need to have the components on your desk. You don't need to be near your desk. You can do it anywhere. And then you can also just save a link. Save your project, share the link, and somebody else can run the same project, pick it up from the same point. So it's really comfortable when you want to collaborate or even just ask a question and not only show the code but show the entire project. And this is a project I've been working on for 2 years. Apparently 2 years are not enough to make a very good simulator. So it's getting better all the time. I'm still adding a lot of features and improving it. But what you will see today is probably different from what it will be in a few months. So one of the things I would love to hear from you is feedback on how to make it better for you. And as Mark said, just like the other sponsors, you are definitely not obliged to use this tool. And if you find that it doesn't meet your needs, then that's totally fine. But I will really appreciate if you tell me why, because I would love to know that. So without further ado, let me try to share my screen and see if we can see WokWi. Share screen. Screen one. Whoo! And me. Andrew is asking. Yeah, let's move this StreamYard away so I can still see the question. The question already started before I showed it. So Andrew is asking whether this is a cycle accurate simulator. So as usual in engineering, the answer is it depends. It tries to be cycle accurate, and for those of you who don't know what cycle accurate is, it means that if something in real time takes half a second, it will also take half a second in simulation, and it's really essential for things like communication protocols, because things like those NeoPixel LEDs that you have, or some of you probably have on your in your projects, they are very sensitive to timing. So if you don't get a timing right, then they will just not work. And the whole point of the simulator is to know if it will work or not on the real hardware. So Arduino simulation is cycle accurate. And the other question for the same guy was whether it's real time. So let me show you. Let's just pick up the Arduino Uno And I can let's make the font a bit larger. I have this simulation environment, code on the left.
I can make it a little bigger this way.
Perfect. Code on the left, Arduino on the right, and we can just write hello world program, print hello world. I'm bad with caps and spelling apparently, and then I can run the simulation, and you can see on my PC it runs 100%, and if we add an LED, for instance, and pardon for not adding a resistor here. I'm just too lazy, but if you do this, then please add a resistor as well. And then pin mode LED built-in output, and writing blink for the 1000 times in my life. So high, delay 1000, and then the second thing, the same thing with low. So yeah, we have blink here on Arduino, running on Arduino Uno, and you can see it's running real time, like the LED is blinking once a second. And for the most part, the simulation can keep real time, but then in some more demanding boards like the Pico, sometimes the simulation sacrifices the cycle accuracy in order to speed up the simulation. So it's sort of trying to balance. Whenever there is like something that is sensitive to timing, like if you are familiar with the internals of the Pico, there is the PIO peripheral, which is very sensitive to time. So it always runs that cycle accurate. But once it has like something like higher level code, it sometimes tries to optimize it to squeeze more performance and get you real-time simulation. Let me show you actually an example where this fails. So if we go here, there is this project with 32 servos. Some very ambitious person decided to connect 32 servos to an Arduino Mega and make them dance. And if I run this simulation, you can see it's a bit, the timing is a bit slower than real time on my PC, which is pretty strong. If you try it on your PC, it will probably be a bit slower. So this is an example where the simulation is just a bit too demanding to run in real time. So long answer to a small question. It usually is cycle accurate and usually tries to run in real time, but it really depends on what you are trying to simulate. So that was like the simulator. And I think before we go to the Pico, I want to show you one more thing. You can like define the circuit by adding parts and drawing the connections like we did before, or there is like a file that you can edit. So this is pretty useful because sometimes you want to do some kind of massive editing. For instance, I have those servos, and let's say I really hate red for some reason. So I can just, select all those servos defined here, all their horn colors, and change them to, let's say, yellow. And there we go. I did this mass edit by editing a text file. So there are quite a few programmers here, and I guess you can appreciate why it's useful to have the textual representation in addition to the graphical representation. So you can edit it. And I've actually seen examples of user who auto-generated this. I don't know if I can find it here, but there was some crazy, maybe it's in my favorites. There was some crazy person who actually created the WokWi logo. Where was that? Yeah. And I'm pretty sure he didn't like do it all by hand. He probably generated this
Oh,
diagram
wow.
using, it was like, I think it was on the anniversary or some event. I woke up in the morning and just saw this, and I was like, wow, this is,
That's
people do
intense.
really, I agree, people do like, wow, cool things when you give them the tools. And I'm really looking forward to see what, let me show you just one more thing. Oh, this is also someone crazy. He did like, this is Arduino Mega, and he connected LCD displays. So these are LCD displays. I think they are like, let's count how many. So there are like so many of them. All those are LCD displays, and he just used a soft I2C library, so he could like create many I2C buses, because oh, I just messed up his diagram. Never mind, we'll reload. Don't tell him. So if you run it, it's actually, you can see it's sort of a clock that starts counting the time using like it's one of those examples of these things that is so useless, but it's so like, I don't know the word how to describe it. How would you describe this kind of project that is useless, but you have to make it nevertheless?
Um, Cathartic. It gives you a sense of satisfaction at the end.
Exactly. So so just like the dancing servos, and I could go for hours talking about showing just things people did. I will leave you with just one more with fast LED animations. Somebody
Whoa.
did. Yeah, he did like. You can see there is a lot of code here, and it was one of the things that somebody posted on Discord. This guy Steve from the UK. He posted it on Discord, and I was like, "Wow, that's amazing!" So I was
Wow.
spending a few, I think, a couple of hours like going through the code and seeing trying to understand. He used some kind of compression library to compress the animations so they would fit in like this
That was going to be my
memory.
question. How he was able to put all that raw data in. Wow.
You can see here like he has like those comments showing this was like the original GIF size, and then that was the payload size, and then this is how we compressed it. So that's like instead of this file size, he compressed it to 64 bytes using this heat string algorithm. So
Wow.
pretty brilliant stuff. And
Still a lot of
yeah,
data. Wow.
indeed. And I'm always amazed by how people manage to push this into like beyond the limits of what I imagined is possible. This is like, so somebody asked me to add a legacy TV part. So this one simulates those old CRT TVs that you had in your probably like 30 years ago.
Hmm.
And somebody created a Flappy Cat for this TV. So, uh, yeah, I'm pretty bad at it at this game. But yeah, like people do things, and I was like, wow, you are amazing. So one thing I'm not really good at is making sure all the cool projects get visibility. So if you have any ideas, suggestions how to improve that, I'm all ears.
And Uri, aren't you also looking for help programmers if somebody's interested in supporting your project?
So of course, I'm always looking for help, and thanks for the questions for this question. I almost forgot about it. So programming is one thing. Also, like if you create something cool, let me know. I really need help spreading the word. So anyone who creates something new and I can share it with other people, that's great. People see what can be done. This give them inspiration to do cool things. And if you are, even if you are not really good at programming, but you are good at writing. I'm really struggling to write good docs because English is not my first language. So I'm trying my best, but I'm sure like the docs can be better and more beginner friendly. And right now they are a bit lazy and they won't load, but there is actually one person, one user who translates everything into Portuguese, which I really find amazing. So I have very good experience getting help from people from the community. So this is one example. Another example is so if you go here and you see this menu and this toggle grid function, it wasn't there like a week, 3 weeks ago, and then somebody asked for it in the Discord. So we have this Discord for WokWi, and somebody said, some user said, I can do it. I have some experience in working on CAD stuff. So I gave him access to the source code, and he did that. You can see that the wires, they, I hope it's big enough, but they snap to the grid. So they only go through to on grid points. So he did that, all that grid implementation and the snapping, and just sent me a pull request, and I was like, wow, that's amazing. And now everybody can enjoy this feature. So thanks. I mean, thanks to you, thanks to Tim who did this. Yeah, definitely. If you want to contribute by writing code, by writing documentation, by just creating cool things like those things you have seen on my favorites, my favorite project, just please go ahead. I will be really happy. And I know that sometimes we are adding new parts all the time, and there are like, I think you will find most of the common parts, but people always have like more specific needs. So another thing you can do if you want, there is this roadmap page, and this is something new I've been trying for the past few weeks. So if you want to something to be added to the simulation, you just go to this page and there is a link, and then you can click on it and open an issue on GitHub, say what you want and describe it, and then once it's there, it starts appearing on this page. And this page includes all the features that user asked for, proposed, and then everyone can just go and buy vote powers and use those vote powers to vote for the feature. So you can see this is really helpful for me because it really helps me focus on what people really want. So you can see there is like an endless list of features. Some of them like copy-paste components, which is pretty new, still don't have any votes. Some of them have few votes. Some of those on the top. This is actually almost ready, so it will probably, maybe if I refresh the page. Yeah, I refreshed the page and it was gone. It's ready. Yeah, so yeah, I just finished it like a few hours ago, so now it's gone. Yeah, it was a touchscreen. Somebody asked for a touchscreen for the, let me show you. So this is like one of the most recent features. It was this one. So just, an LCD screen with a chat screen running an app written by Adafruit, and the app is, just copied it from Adafruit examples, and then you can like start drawing T forgive my not very pretty handwrite with a mouse, but TMPCB.
Nice.
Yeah, that was supposed to be a check mark. Yeah. So this is a good example because this is a feature that a user wanted. They opened an issue on GitHub and then it got votes and now it's there and everybody can use it. So that's another thing you can do. You can suggest or ask for things that you need, and you can go and support the project financially. And by the way, also vote for stuff and help me prioritize what's important for you. You can see there is like Wi-Fi for the ESP32 that is probably coming soon because it's second on the list, or SD card drive. So there is a lot of work for me. And again, as Mark said, you can also help with the work if you like. I would appreciate that. Some of the code for the simulator is actually open for GitHub, so you can find like the sources for the AVR simulation and the Pico simulation on GitHub if you want to learn how it works behind the scenes. There is for the Pico specifically. I think it's a good time to switch speaking about the Pico because that's what you are going to use in your boards. So for the Pico specifically, there is a series on YouTube where I recorded all the steps when I built the simulator from the very beginning. So I think it was like a week after the Pico came out. So there is like a series on YouTube where you can see me coding a simulator from day zero. And adding like all the instruction set and all the peripherals, UART, SPI actually I think I added later, but the UART, the USB, the timers and everything, GPIO, everything that is needed for the simulation. So it's pretty long. There are like 30 sessions of 2.5 hours, something like that, but you can actually see how I built the simulation, how I coded it, and how I introduced hard to find bugs and then pulled my hair later trying to figure out what's going on and what's wrong. Let's switch to talking about the Pico. So for the Pico, there are actually 3 ways you can work with it. The first one is like very similar to Arduino, run Arduino code on the Pico. And here is something for those who asked about the real time. So this is a simple piece of code that prints hello Raspberry Pi Pico and then goes into an endless loop. And I could add an LED and blink it, but we already did it, so I don't think it will be very interesting. But somebody asked about the speed of the simulation. So right now it's running at about 100%. But if I remove this delay, you will see that it won't be able to keep up at 100%. It slowed down to about 50%, something like that. And the reason for that is whenever there is a delay, the simulator actually sees that the CPU is waiting for an interrupt, so it jumps ahead in time, and therefore it's able to keep the cycle count accurate, so keep the simulated time accurate, but not spend a lot of your own CPU time in simulating this do nothing loop. But as soon as you remove the delay, like we did now, the simulator has no idea that this code is an endless loop, so it just runs code, and there is it runs the code 100% of the time. Like it can't skip or do any kind of optimizations, and then you get like a slower rate. So sometimes you can by adding delays or waiting for interrupts, you can help the simulator to run at 100%. Or you can just buy a 10 gigahertz CPU and then it will just fly. if you find one on the market. So that was one way to, oh, I lost my, I lost my pipe. That was one way to run the simulation. And I see some that I've seen in the, in your answers in the chat that many of you actually worked with Python. So there are two ways to use Python on the Pico. There is MicroPython and there is also CircuitPython. And CircuitPython is pretty new. You run it and it shows you the output of the code in a small terminal, and you can do stuff. But I think for the course, Mark said that he would love to focus on MicroPython, right?
Let's ask, do you guys want CircuitPython or MicroPython? Or actually, Uri, what's quickest for you? Let's do that instead.
Wise, smart call. So yeah, yeah, actually, I will be honest. I have no idea if everything is going to work in CircuitPython because it's pretty new. So it's probably, but let's be less adventurous and go to MicroPython, which is more battle tested. So it's very similar. You see, it's a Python file, and then you run it, and it runs the code. And once it finishes running the code, you get into the REPL, so you can start doing stuff like, let's say there is this LED here on the board, and it's connected to pin 25. So I can, from machine, import pin, and then LED is pin 25, and it's an output pin. And then if I call led.on, you will see here now, it turns on, and led.off, it turns off. And then I can do like import time. And you know what? Instead of doing it in the REPL, which is like annoying, I will just copy this code here, and we can do it here. So just our first MicroPython code on the in the simulator, and it will be blink, of course. So while true, time.sleep1, and another time.sleep1. Actually, we can make it shorter. There is a toggle method that will just toggle the LED, so we don't have to switch to alternate between on and off. And now if we restart the simulation, you can see the LED is blinking. And that means we are ready to take over the world.
Woohoo! I know I'm ready.
So I was born ready. All right. So actually, there is one, I wouldn't call it problem or challenge with the Pico, but there is one thing that you need to know. If you want to drive NeoPixels, then it's not very straightforward on MicroPython. At least I haven't found a built-in way to do it. You would have to go through the PIO peripheral, and that takes a lot of code. Luckily, people have already done this, and there is like a library that you can use. Let me find it. So I prepared a template, which is, you can see it's very much the same thing, but it also includes this library as another file, so you can just use it. And you can just Google NeoPixel RP2040 or Raspberry Pi Pico, download the file, and then upload it to the simulation. But I did it for you to make your life easier. So right now the code just says hello there and does nothing, but we can let's add a NeoPixel ring, and we can connect it to one of the pins. Let's say pin number 6, just for the sake of it. And the simulation doesn't require you to connect the GND and the VCC pins, but it might change in the future. So it's always best to connect the supply pins and not leave them disconnected, even though it will still work. So let's do that. Here I'm not as neglectful as I was with the resistor. So we have a NeoPixel ring, and we can start a simulation again. And now we can just, import this from NeoPixel. So from this library that we have here, import NeoPixel. And we can set it up. So pixels is NeoPixel. And then we have, I think, 16, right? Yeah. You can, by the way, change the number of LEDs you have here just by changing the number here to any number that you want. So we have 16 LEDs on PIO number 0. You always write here 0 or 1, but usually you just see 0. And pin 6 and the RGB, that's the standard color are there for NeoPixels, and you basically don't need to remember this. You can just copy it from, I think there is an example somewhere here, or where I copy this library from. Sorry, I don't remember. Next time I will give credit. Anyway, we initialize the pixels, and now we can just call pixels.setPixel, and let's say set pixel number 5 to, and if there was, it was like a live show with the audience, I would ask the audience to shout at me RGB numbers, but we still have Mark here, so go ahead.
Do you want them in hex or decimal?
Your call?
B6.
All right, and?
E4.
And?
13.
13, okay. So, it didn't do anything because I also need to call pixels.show. And now, voila, that's your color, pixel number 5. So, thanks. So, this is like showing one of the elements that you have on the boards, the NeoPixels, and this is how to use it with MicroPython. And let's just copy this code, and I will update this example and then share the link with you so you can use it as a starting point. And let's make it a bit more interesting. Import time, and then we can do while true, and just set pixel index to 0, and then every iteration just sleep for 0.1 seconds, and set the next pixel to this color, I guess. And then we just need to do pixel index plus equals 1 if pixel index equals 16, right? The last one, then pixel index goes to 0. And to make it more interesting, let's make it alternate between 2 colors, so it won't be super boring.
Oh, would you like another one?
Yes, please.
42. D1.
And
E0. And the last one is
E0.
E0.
All right, perfect. So now we can do also color index, and we can go by colors at color index. And whenever we get to the end, we can just, color index should start from 0. We can just say color index equals, we will take a little shortcut here and just modulo 2. That's a way to make sure it never goes beyond 2. So it will toggle between 0 and 1. And I could have done it with just this way, plus equals 1, and then with an if, but that's a shorter way. And let's see, will it work on the first try? What do you say?
Yes.
Let's see.
You're Uri. Of course it will.
It does, but in a
It
bit
is
of
a little-
strange way.
Yeah.
Yeah, I
wasn't
think
going to
if
say anything, but yeah.
I think I think one of the things with the protocol, sometimes it has like some timing things, and you need to add another pixel. So let's see if that fixes the issue. No, not really. So seems like I'm going to spend some time debugging this night to figure out if it's my problem. Usually it ends up being a problem with the library, but I can't say that for sure until I tested it and compared to the real hardware. But yeah, it sort of works. Let's see if I can find it. It might also be a problem with the code. Let's see if I can spot this real quick. Did anyone in the chat spot a problem with the code? So pixel, oh, let's just print pixel index and colors at color index to see if we haven't been doing anything bad. Yeah, it seems pretty well. So yeah, I will actually, the colors aren't alternating. That's one problem I can already see, right? Oh yeah, I forgot to +1. So that was a bug in my code, but I don't think it will fix this sort of flickering that we have. But at least now the code is flickering but functional. So
Should you?
yeah.
You want to try increasing the time? I don't think that'll fix it, but go from 0.1 to just like 1.
Well, you
we'll
didn't
see if we
think
can-
that would fix it, but it didn't fix it.
Didn't, no.
But
I
you
just
know
wanted
what?
to see the problem happen a little slower.
A little slower. So that's a good opportunity to take a look at one of the most useful tools here. It's the logic analyzer. So, you know, I can just add a logic analyzer, connect it to the ground, and then connect this to the data pin, the same pin, and just run the simulation. And now it's recording all the data that is sent to the NeoPixels. I have a file, I can open it, and wait a second, and then I can just, you know, view the signals, see the actual signals that are going to the LEDs. So that's pretty advanced, but this is actually how I debug this kind of things.
Oh, that is cool. So
Thank you.
One of the things people might not realize is what we're building to is we can actually write code for our boards before you ever finish designing them, before you order them. And that's often the case in professional environments, that you will have a firmware engineer as talented as Uri, and then you will have a PCB designer more talented than me, and they can be doing their job simultaneously instead of waiting for the board to come in to start writing code.
So yeah, actually that's another thing. So I'm going to save this code and I will share the link here so you can share it on the chat. So if anyone wants to look into it, and you know, you have the logic analyzer, you can delete it if you don't want it. But either you will find a bug, either I will find. So let's see who finds it first. I want to show you something which may be a bit more relevant. I prepared something especially for this session. So it's this link, and it builds on one of the features that I just added like 3 days ago, which allows you to load to define and load custom parts. So we are going to F1 and load custom board file. And then I can load a board that I prepared, and it's basically an SVG file. And do you recognize this, Mark?
No, gosh, where did that come from? Was that on HBO last night? No, I'm kidding. Of course, you went to a great deal of effort for that for me.
So yeah, basically, you're welcome. So basically, we took the board shape, and that's something that is like, it's a super new feature, but you can just now import your own board shapes. And it's probably going to be a bit more user-friendly in the future. Right now you have to create a few files, but it's an SVG and a JSON file. If you want, I can show you later how it works. But then other than this, these are all like standard parts, like a NeoPixel and a push button, and there is like a Pico here, so you can see it's defined here, and a rotary encoder. So these are like the parts that you have on your board, and I think some people also have in their projects. And one of the coolest thing here is that usually when you place a wire, like if I place a wire here, you will see the wire, and that makes sense when you are simulating discrete components, but here you don't want to see the wiring. So if you go to the diagram.json and just delete the color, it will hide the wire. So, and I need to remove the comma. So there is like, let me just unhide all of this. So there are a lot of wire, there is all the wiring here, but since I hidden it in this diagram.json file, you just get to see the board without all the clutter. That's your board, and I wrote a really simple firmware just to show to test it sort of. So I also use the buttons using this pin in with a pull up resistor, and also use those neopixels. And there is a very simple code, or moderately simple code, which I tested. It doesn't have bugs. And basically it's just demo mode for the keyboard. Whenever you press on a button, it would cycle between the colors, so you could like just play around with the colors. If you want different colors, you can add them to the array here. And this is like just to give you an idea of not only how you could test your code before you have your hardware, you can also have it be visually similar to your actual board. So you can actually copy the layout from your board and get a good feeling of what it would look like. And I haven't tried it, but I found this library for rotary encoders. So if any of you want to try it, I think this one can also be useful for working with those rotary encoders. If you have those on your keyboard, they say it works on the Pico. I believe them. I haven't tested. As Mark said, this is like something that I would like to see happening. You having the hardware, you having the firmware ready by the time you get the hardware. But if WokWi doesn't allow you to do this for some reason, I would love to know and try to fix that.
Well, it'll certainly, even if it doesn't get us all the way there, like with the light sensor or whatever, it's going to get us really close.
Mm-hmm. Yeah, and I mean, I think there is already like, there is already an open request for this light sensor. So if anyone wants to use it and wants to support a project, then you can just, go to wokwi.com/features and just, click on vote and buy some vote powers and vote for it. And usually smaller parts like this, they don't even need to get to the top. Like once they get a few votes, then we start working on them, because we don't want the smaller features to be blocked by larger features. So we have like different allocations for working, different time slots for working on larger features, such as these humongous features on the top, and other slots for working on like smaller stuff. Like there is this like part which we added, I think, we did it yesterday, this deep switch 8. So somebody requested it last week. It got like 4 votes or something like that, and then we just implemented it in one of those slots for the smaller part. So so if you are missing something, either vote for it or just miss it. Your call.
All right, that's really cool. So I've put up some various links, and these are all recorded in the chat, of links to this. We've got links to your Hackaday series I provided much earlier. I know it's really late over there, but do you have any time for questions?
Yeah, it's
All
pretty
right.
late and I have time.
Okay, it is very late over there. I won't keep you too much longer, but this has been great, buddy. I'm just sharing your latest comment there for the vote feature. All right, guys. So now we've got time for questions. So I've got to scroll way back up. Sorry, it looks like we had a spammer come in. So sorry for those of you that were exposed to that until I got a chance to block him. Where did the question start? So one of them was, and I believe you answered this, do you support STM32? And it looks like you're about to, right?
They are similar, but that's the ESP32.
Oh, okay.
Yeah, so for the STM32, the only way to get me to support STM32 is to get it to the top of this list. Like adding a new microcontroller, it is a really huge. Like if you see the series where I added the Pico, it took me about 6 months of weekly sessions, and I eventually got there, but it's big, and now I'm like working on the ESP32 for like a few months, and now there is also this ESP32S2, which is just a variation, but I've been working on it for like 6 weeks on and off already, just to get the basic functionality working, so you can run CircuitPython on it. So adding a new microprocessor would be at least a few weeks of WokWi. So the only way, if you really want to see STM32, is probably to get it to the top of this list.
Okay. How do you simulate the electrical functions?
So it really depends. For the most part, I only simulate digital, the digital logic. And that's something that I'm always trying to think, how can I improve? So you know what? Let me show you some of the code. Let's see. Wait a second. I will have to make sure I'm bringing it. Wait a second. I will just stop sharing my screen for a second. So I won't. Where is the StreamYard? Yeah. So I won't share any embarrassing chat messages or something like that while I bring the code in. So yeah. So sharing my screen again. Share screen. Screen one. Okay, perfect. So can you see my screen again?
No, I have to bring it in. There it is.
Okay, perfect. So I will just show you. You asked about the electrical functions. So let me show you, like, for instance, the NeoPixel, and that code is also available on StackBlitz. There are like a bunch of example of just the AVR simulator with all sort of stuff. So basically, it's just all very long state machines. So in this case, like for the NeoPixels, there is this class that gets that has a data pin as an input, and whenever the data pin changes, it checks the time that elapsed between the previous change and the current change, and then it compares it to like those ranges of what encodes 0 and what encodes 1, and it basically decodes the bits from the protocol. So this is like the example for like NeoPixels, like 150 lines of code to do this. And if we go, for instance, all those prints that you see on the serial monitor, these are like UART. So there is like UART encoder that does the state machine for like transmitting all the bits of the UART decoder that does the opposite and like decodes the UART protocol. So this is how this is implemented in a very like quick overview. For the digital part. The analog part is still very much lacking. There is, for instance, an open request to add a resistor divider. You can see it's it's slowly getting votes, and some people really want it to be able to simulate a voltage divider. I think it's very useful for educational use. And Andrew, you are very very
Inquisitive.
inquisitive in a good way. Is there a word for that? Posiquisitive. You are very posiquisitive.
There you go.
So yeah, there is a way to debug and step through code, but it's a bit advanced. But since you asked, let me show you this. Those of you who are coming from the C++ background will probably feel more comfortable with this. Let's switch to the English documentation. And there is, like, in the docs, GDB debugging guide. So you can use the GDB debugger to debug the code. For instance, let's just take a quick example and just so you can see it in your eyes. Let's go over to some, let's take just a simple blink so we can see it. So this is like, let's remove all the comments. So this is like the Arduino blink. We have seen this before. It blinks an LED. And let's say I want to debug it and run it step by step. So I F1 and start GDB session. And this will open a new window with, it's actually a bit crazy what you are seeing here. You are seeing here GDB running inside a Linux virtual machine that runs inside your browser. And that connects to WokWi through a WebSocket. So you can see it's like a different domain, but those two windows are talking. And if I go to the simulation, and then I can say, like, I want to break at setup and continue the code. So now it ran the code until it got to the first line of setup. I can actually switch to source mode, so I can, it's a bit, yeah, it's a bit unhappy about making the font bigger. Let's try to restart it. Sometimes it helps. So yeah, a bit better. So now you can see, like, I'm in setup, and then I can type next, and it will go to the next line in code. And then if I type next, you can see I got out of setup. I got back into main, which is the it's jumpy. It's the Arduino main function that calls setup and loop. And if I step into, I will get into loop, and then I can run it like the digital write, the delay, and you can see it stopped right at second one after the first delay. And then I can next again, and so it's possible to step, debug. You can print values of variables, registers, whatever. But there is a pretty steep learning curve with the GDB, so you have to be prepared for that. It's not beginner friendly, but it's pretty powerful.
Andrew had a response.
Oh, wow. Yeah, so yeah, Andrew, if you are interested, there is in the documentation, in the debugging guide, there is like this link at the end which explains how this works technically, like the Linux in a virtual machine running inside the web browser. It was pretty tough to put together, but you know, GDB is so powerful, so I really wanted to have it, and yeah. Mikhail, right?
I'm
What
not
technology
sure.
is used to? Well, maybe Mikhail. I don't know how to pronounce this. What technology is used to build the simulator? Is it TypeScript only? So it's a combination. Most of the code is written in TypeScript. And you can find like the actual CPU simulators for Arduino and Pico are on GitHub, so you can find them at github.com/WokWi/ let me show you. So github.com/WokWi, yeah, github.com/WokWi basically. So yeah, let's go there. So you can find the AVR simulator, that's AVR AGS, and there is like the RP2040JS, the Raspberry Pi 2040 simulation. And there is also another cool project called Elements, which you can find all the, there is a page showing them here, all the user interface elements for all the parts. So if you want to create your own simulator project, you can just take those elements and include them in your project. And then you just have to write the logic, but at least you have the user interface for those parts. So yeah, so for the most part, it's TypeScript, and then there are like a few things that are using WebAssembly, and I hope to write about that at some point. But for instance, when you start a simulation here, there is, you don't see it, but there is a piece of code that runs in order to upload your Python code into this simulated environment. So if we go into the code, and yeah, what happens here? For some reason I can't I can't break, but let's just remove this for a moment so we get into the REPL. So yeah, so now I'm inside the MicroPython REPL, and if I import os list dir /, you can see there is like all these files in my project are copied into this simulated environment. And what happens behind the scenes is I create a little FS file system. So I create a file system and copy all those files into it, and then copy this file system into the simulated Flash. And instead of like going through hoops to implement this pretty complicated file system called little fs in TypeScript, I actually use the original C implementation, but I compiled it to WebAssembly so it runs in the browser. So there are a few pieces of code that are written in C and compiled to WebAssembly. One more quick example. If we just create a new project, and that's something like beginners really like to do. They create a project and they write their code like this. And you see, no indentation. They just don't think it's important. I never indent. So luckily there is an hidden feature. They do, like if something, then you have like 5 different levels of nesting. Maybe there is, I would be shameful if it's true, but I think there might be even an example. No, this one is probably properly indented, but yeah, there are like some projects, good one that I have seen where they don't do the indentation. So if you F1 and format document, you see it fixes the indentation and everything. And this is also implemented in C. It's the same formatter used by Arduino. It's called A-Style, and I compiled it to WebAssembly so it can run in the browser. So I don't have to implement all this logic into TypeScript to write like a parser for C++ and all this pretty long but boring logic to format code. I don't want to do it. So yeah, it's already done.
I'd also like to let people know that WokWi supports assembly language. It's an incredible bit of software. If you ever, not ever, but if you do get the chance to watch Uri live stream code WokWi's back end, it's incredible. He moves too fast for me to keep up. I have to play him back on like half speed. It's it's pretty significant. And I'm going to tell you something, Uri. I was going to take your code and load it on my board tonight because I haven't had a chance to actually bring it up and put any code on it, but I can't because I learned last night that I put every single one of my LEDs on backwards, all of them. At
Well,
least I learned it before I put power onto it. But yeah, Jesse pointed out that they tagged pin 3 instead of pin 1. Who does that?
oh, so they
Monsters.
just, yeah. I also had it. If you want, I can look it up later. I ordered like 10 pieces of PCB that I did for some conference. So I ordered them assembled, and they tagged pin 3 instead of pin 1. So I got all the LEDs incorrectly placed. And then I spent a night working with a hot plate and a pair of tweezers, just picking up an LED, rotating it, putting it back, picking up an LED, rotating it,
Oh,
putting it back. It was
no fun.
like awful, yeah. But at least maybe I still have this PCB here somewhere. That's the problem. Oh, yeah, I think, yeah, there it is. There it is. Yeah. So this is the little
Let me make you big
troublemaker.
here. Give me 1 second. I need to make you big. There we go.
Yeah, yeah. Maybe I can. I don't know if it works, but no, I don't have it handy with me. I was so it's part of name badge I was making for a conference, and I thought I might be able to show it in action. But I don't have it handy at hand. But yeah,
Not a problem. Not a problem.
I also suffered from the very same problem with, math is hard, but
Yeah. Yeah. So, well, hey, my friend, this was great. I really appreciate having you here. For all our viewers out there, Uri is on our Discord, so we have complete access to him, and you might want to go check out his WokWi. It's much more active than our little Discord is. I'm also going to, within the next couple days, add a section to the website for the coders that want to go ahead and start programming now. You guys will have a place to play around at TeachMePCB instead of waiting until the end, when we order boards. Any final thoughts, my friend?
well, I think the only thing that I would love to get is feedback from everyone who have seen this session, and as you said, on Discord. So feel free to reach out and tell me if there is anything missing, and if there isn't anything missing and you want to help or contribute, you are very welcome to do so.
And I'll vouch for Uri's character. He's one of the nicest people you will ever have the chance to meet. Dances, plays saxophone. There's nothing this man doesn't do.
I don't really play the saxophone. I tried to.
I've seen videos. I didn't say it was good, but I've seen it.
Yeah. The thing is, I was cat sitting at a friend's house in Palo Alto like 6 years ago, and it was pretty boring. Like, I don't know if you know Palo Alto, but it's like, it's families. There is nothing to do there. So I got really bored, and I decided to rent a saxophone for the week and just, try to practice each day and see if I can get any sound out of it. And well, you have seen the videos, you can judge.
No,
But it kept me busy for the week.
you're getting people who very much appreciate your time today. There's quite a few comments that say thank you very much, amazing work, very impressive, that sort of thing. And I'm sure you've made some friends today too. So hopefully you guys will go check out WokWi's Discord and see what's going on. So thank you so much, my friend. It's really a pleasure having you be part of this class. I can't tell you how happy I am that I don't have to write the code, that you've already given us the base for it, and we can build from there. That's wonderful. So thank you so much, and we'll see you around Discord.
Thanks for hosting me, and see you.
All right. You're welcome back anytime. Take care. Bye.
Bye bye.